Okay, so we're looking at question 10 from the 2013 exam. So the question asks us to write down the dual of the following LP problem given here, and there's a note saying that we do not have to solve this LP problem. Okay, now firstly I'm just going to write the definition of the dual on the right hand side here, so we can use that for a reference for this problem. Okay, so this is the definition of the dual. So given we have a maximization problem in this form, the dual can be written like so. Now these A, B's and C's are all matrices, and AT, BT and CT are the transposes of A, B and C respectively. Now X here is the matrix of the unknown variables. In this case it's the 2x1 matrix X and Y, and the U matrix here is a matrix for the new set of variables that we'll use for the dual problem. Now the specifics of the matrices A, B and C I'll explain using the LP problem that we've got here. Okay, so there are actually two ways of going about this problem. The second way I'll give a brief description at the end, but we'll do it the conventional way, which is to convert our LP problem into a maximization problem and then rewrite all of our constraints so that we have less than or equal to signs for each of these constraints. Okay, so firstly let's convert this minimize into a maximize problem. So to do that we write the word firstly maximize, which you might have guessed, and then we multiply both sides of this objective function by -1, and that'll give 3x minus 5y equals -8. Okay, and then we can rewrite the constraints from here, and the only one out of these three that's in the correct form is the second constraint, as we have a less than or equal to sign already there. So to make these less than or equal to signs, we multiply both sides of the inequalities of constraints 1 and 3 by -1. So that'll give us -2x plus y is less than or equal to 3. The second constraint remains the same, but we'll rewrite it anyway, just so that we've got it in nice columns and rows. And then finally we have -x minus y is less than or equal to -1. Okay, so now we have our LP problem in the form that we're after here, that's given in our definition. So we can then quickly write the LP problem out in matrix form. Okay, so here's the LP problem rewritten in matrix form, and that corresponds, and these matrices correspond to the matrices given up here. Okay, now let's go ahead and write out the dual. Okay, so from the definition we can see that we now have a minimization problem. So we write the word minimize, and we give ourselves some y being equal to the transpose of b, which is 3, 6 and 1, and they'll now be the cost coefficients of this objective function in front of the variables u1, u2 and u3, because we have a 3x1 matrix here. We need 3 variables. So we write that out. We have 3u1 plus 6u2 minus u3. Okay, now we can give ourselves our constraints, and the coefficients of these constraints will come from the transpose of the original constraint coefficient matrix. So we'll write those out now. So we firstly have -2 for the first constraint, multiplied by the first new variable, and then we have the second constraint coefficient here for the new variable, and then the third one here. Okay, and then we give ourselves a greater than or equal to sign as per the definition, and then we take the first element of the transpose of the original cost coefficient matrix, which in this case is 3. Now notice that our minus z is our z in this case, as we've set it out like so. I probably should have avoided using z in this case, as it's also the objective function of the original minimization problem, but you'll just have to bear with me that this minus z is the same as this z. Okay, so we write down the first value of C transpose, which is 3. Okay, now for our second constraint, we look at the second column here of our A transpose to give ourselves our constraint coefficients. So let's do that. We now have U1 as the coefficient is 1 for U1, then we have plus 3 U2, then minus U3. And again give ourselves a greater than or equal to sign, and then the next entry into C transpose is minus 5, so that'll be our value on the end there. Alright, and one final thing, and one very important thing if you want to get full marks for this question, is to make sure that you include this last piece of information here, given in the definition of the joule, and that is that U1, U2, and U3 are all greater than or equal to 0. Okay, so that's it for writing out the joule. And again, just a side note, if you did want to just go about this question without writing out all of this stuff up here, it's fairly easy to do so. If you just notice that the original matrices all come from this information here, and if you just sift through the information you have, you can very easily just notice that our 3 and minus 5 here turn into our numbers at the end of the constraint here. Our 3, 6, and 1 at the side here are the new cost coefficients, and the constraint coefficients here just turn from being read across to being read down, and they will be your new constraint coefficients for the first constraint, and the second column here will be the new coefficients for your second constraint here. Okay, and that's all I've got to say about this problem.